So here we're going to be looking at coordinate geometry, specifically recapping some of the coordinate geometry we would have looked at junior cert and revising some of the formula that you would have learned. So if we go back and think about geometry, well, geometry has to do with the shapes and the positions of various things, figures, and coordinates. They refer to things like ordered pairs. So if we have an x, it's got its corresponding y. And through that, we look at this through the Cartesian plane. So the Cartesian plane is basically a two-dimensional plane where we can pinpoint certain ordered pairs. So for example, if I just picked a random spot like that, this point would have a certain x value and then a certain associated y value. And I could write that as an ordered pair like that. Just so happens that that x value and that y value are related to each other in some way. If I picked another x and y value, I could pick a point there, and that would have some x value and that would have some y value. We could call that x1 and y1. So what I've created there are points on a Cartesian plane. And a point on a Cartesian plane just has certain properties. It's moved a certain distance from the center of the Cartesian plane, which is at 0, 0. It's moved a certain distance across and it's moved a certain distance down here. And that distance across, I'll just call its x-coordinate, and that distance down, I'll call it a y-coordinate, and it's just a number. But if we remember from junior cert, we're allowed to figure out a lot of properties about these 2 points using different formula. So for example, if I wanted to know the distance between the points, then I would use a certain formula according to the log tables. If I wanted to connect the 2 points in a line and figure out how they're related in terms of the direction of that line, I could work out the slope. If I wanted to figure out the midpoint, for example, between the 2 points, i.e. the point that was halfway between, I would just use the formula. I could also divide the line into certain ratio and things like that. And that's what we learn about going forward in the next couple of videos. So what we know so far about coordinate geometry, it deals with points on what's known as a Cartesian plane. Don't worry too much about that. It just basically means we have a two-dimensional axis, one of which is horizontal, which is this x-axis, one of which is vertical, which is this y-axis, and along the x and y axis we can create certain points, and from those points we could work out the relationship between them. For example, if I picked another point here, this would then have a certain value here. That would be its x value, call it x2, and then it would have a certain y value here, call that y2, and now I would have created 3 points. Well, with 3 points, if I wanted to connect them, then I'd create a triangle. Okay, I've created a triangle. What does that tell me? Well, we could work out the area of the triangle, so we could work out the complete area covered by those 3 points. We could find the center point of that triangle, so the point that's equidistant from all 3. And we can convert that then into a separate system. Let's say we were looking at maps. We could look at distances between points and see, well, what was the best distance to meet if we were looking at 3 different kind of locations. So there's loads of things we could do with coordinate geometry, and this is just an introduction. So I'm going to bring across some of the formula now, and we can have a look at some of them. So I've given them their points, roughly where they are according to the plane. So A here, the first one is 3, 2, because the x-coordinate is 3 across there, and the y-coordinate is up about 2. Then here my x-coordinate is 1, and my y-coordinate is down by 4, so my y-coordinate is down here. And for this one, my x-coordinate going across is -4, and my y-coordinate is 1. So if I wanted to work out, let's say, the slope of the line between A and B, I would just use that formula there. Another way of thinking about the slope is that it's just rise over run. So it's going to be the change in the y values over the change in the x values. The slope between A and B here will be the difference in the y's, so it doesn't matter which one I take first, but as long as I do the same thing to the x-coordinate. So I will take 2 minus -4 over the difference in the x values over 3 minus 1, which is equal to 2 minus -4, which is 6, over 3 minus 1, which is 2, and that gives me a slope of 3. So what this slope basically tells me is that the line that goes between A and B as we increase x, y increases a lot more. Hence it's a positive slope here. And we can see that that happens here. So as b goes to a, x increases by a very small amount, but y increases by a very large amount. So we get a positive slope. What can I do with that slope? Well, I'm able to work out the equation of that line between them. So the equation of the line, if I look at the formula for equation of the line, which is this one here, I'm told to write the equation of the line. We simply use a formula, which is y minus y1 equals to m times x minus x1. So for this, we just can enter in any coordinates that are going to be on the line that I'm talking about. So if it's the line AB I'm talking about, then it's going to be y minus y1. Well, if we're talking about AB, we can use either of those 2 points. So let's use a, y minus 2 is equal to the slope, which is 3, I worked that out above, times x minus the x value there, which is 3. So that equation becomes y minus 2 is equal to, expand the brackets, 3x minus 9. And we can write this in a number of ways. So I can write it like y equals to, bring the 2 over, so add 2 to both sides, 3x minus 7. That's one way of writing it. I could also just write it with all on one side, so it would be 3x minus y minus 7 equals 0. This way is a really useful way for writing the equation of a line, because it allows us to actually straight away pinpoint some information about the line. So what I can find is, if I have isolated y on the left hand side on its own, then the coefficient of x will always be my slope, as long as y is on its own, and the y-intercept, which is the point at which the line crosses the y-axis, will be equal to the constant here, so long as y is on its own. Well, why is that? Because when the line cuts the y-axis, the x value is 0, so y is equal to minus 7. So that is the equation of the line AB. That equation of the line tells me that if any point with a certain x and a y value satisfies this equation, then that point is on the line AB. Likewise, if I pick a random xy value like 1, 1, I can show that that's not on the line AB, because if I plug in the 1 and the 1, 1 for y equals 3 times 1 minus 7, well, that's just not true. So therefore the point 1, 1 is not on the line. So let's look at some more things with the equation of the line. If I wanted to find the equation of the line AC now, 2 things I need to do. I need to find the slope of AC, and then I plug in the coordinates into the following equation. So the slope of AC is going to be the difference in the y's over the difference in the x's, i.e. we're looking for a number which represents the change in y with respect to change in x. So the slope will be 2 minus 1 over 3 minus 4, which is equal to 1/7. Okay, so 1/7 is a lot less than 3, so I'd imagine that as y increases with respect to x, the gradient of that line isn't as steep as the gradient of the line AB. Well, we can quickly look at that. That is in fact true, because if this is my line AB, quite steep, and this is my line AC, then we can see that the line AB is a lot steeper than AC, and so therefore it's got a higher slope. Then to work out the equation of AC, we just plug it into the equation of the line above, so it's going to be y minus some of the values in A, either A or C. So if I go back, I can look at, let's plug in C this time, y minus 1 equals m, which is the slope, so that's 1/7 of x minus the x value of C, which is minus 4. So to answer that then, whenever I have fractions on one side, I multiply both sides by the denominator, so that's going to be 7 times y minus 1 is equal to x plus 4. 7y minus 7 equals x plus 4. And rewriting that equation, we have 0 equals x minus 7y plus 11. If I want it in the other format, again, the slope of this line is 1 over 7, and if I was to cut to y-axis, it would do so at the value of 11 over 7. Now, one thing we could do is we could actually see the point at which these two lines intersect. Now, I know the answers to this already, but this allows me to bring in some algebra into coordinate geometry, because the point of intersection of any two lines is a point that satisfies both equations. So you can carry out some simultaneous equations with these. So I'm just going to rearrange both equations just to put it into the standard fashion we're used to. So I've multiplied it by minus 3 there just to add the two lines together, and we're left with 20y is equal to 40. So y equals 2, and if I plug that value of y into the original, 3x minus 2 is equal to 7. So 3x equal to 9, x equals 3. So the point of intersection between the lines AC and AB is the point 3, 2, which unsurprisingly is the point A, because we know that the orange line there and the yellow line intersect at A. So we can show that graphically or geometrically, and we can show it using algebra. So I'm not going to go into a huge amount more there in the recap video. We've seen that we can use points in a Cartesian plane to find some interesting things about the points and the distances between them, even though it didn't use the distance formula, but the equation of the line, and we looked at the slope. If I wanted to find the area of the triangle, for example, I would just take that triangle and translate it, which is just basically move one of the points to 0, 0. Then I would move the other 2 points by the exact same amount. So I'd basically translate the entire triangle with one of the coordinates now being on the origin, which is 0, 0. That would essentially mean that the area will obviously be the same because we've translated each point by the same distance, and from that we're able to just plug in this formula to find the area. Okay, and we'll be using the other formula a bit later on.